So if you are doing roots in the calculator or typing them into a computer at all, you'll find very quickly that it's really pretty annoying to type nth roots into the computer. The computer was just not set up to have the symbols to do this easily. And even in your graphing calculator, which theoretically is designed for stuff like this function is buried all the way back sort of in the catalog. This one's quite hard to find. So instead, we're going to talk today about another way to write nth roots that's much easier to type into the computer, and in fact has many more advantages that we'll see as we get toward the end of this chapter. The exponential form of roots. If I want to express the nth root of a in a way that is easier to type in the computer or into the calculator, I would type a to the power 1 over n. So for example, if I wanted to calculate the third root of 27 by calculator, I would type in 27 to the power 1/3. This is how you would get it in the calculator. 27, a caret for exponent, and that exponent in total is 1/3. So just as a point of warning, if you have something like 2 to the power -3, that is indicating to you negative exponent. Put 2 to the power 3 in the denominator of a fraction, you get 1 over 8. But if the exponent itself is a fraction, 2 to the power 1/3, that is a very different meaning. That is shorthand for the cube root of 2. So negative exponents become fractions. Exponents that are already fractions become roots. Okay, so let's try with this example where I have the cube root not of a number, but of a variable x. To rewrite this in exponential form, I would just have to take that radicand of x and rewrite it as 1 over 3. So a division by 3 at the exponent level, 1 divided by 3. Now here, if I'm trying to rewrite in exponential form, the square root of x to the 5th power, it's worthwhile to acknowledge, first of all, that a square root has an index of 2 being implied, 2. So this becomes a division by 2 at the exponent level. X to the 5th to the power 1/2, or x to the 5 divided by 2. Division at the exponent level by the index.